Hey everybody, Mr. Cornell, ready to go over measuring radians and unknown lengths and area problems. And so when we go through this, we're going to be talking a lot about that word radian. So by definition, a radian is the measure of a central angle when the arc it subtends is equal in length to the radius. So what that comes down to is basically, here's a little picture here where they're showing you a 1 radian. And then here's that arc that was created from that. Basically, in English, what a radian is just another way to measure an angle. Okay? So when I'm looking at this here, it says it takes 2 pi radii to go all the way around any circle. So the circumference is equal to 2 pi r. Okay? Therefore, 2 pi radians equals 360, which makes sense because in order to go all the way around a circle, it has to be 360 degrees. So when we're measuring, again, radians is just another way to measure an angle in the triangle. So sometimes it could say it's 2 pi, and if I said it's 2 pi radians, it's like saying the same thing as 360 degrees. Now, we can convert radians to degrees and degrees to radians by using this formula. So 1 radian is equal to 180 divided by pi degrees, or 1 degree is equal to pi divided by 180 radians. So in this first question, they say convert 270 degrees to radians. So here you have 270 degrees, and I want to have an answer in radians. A helpful hint, because you're going to say, well, which formula am I supposed to use? Well, radians is going to have pi in it, right? So if I have 270 degrees, I want to get rid of the degrees, basically, and I want to create or get pi in there. So what we're going to do is we're going to multiply that by pi over 180, because 180 represents the degrees, so in doing that, you're actually canceling out the degrees. And basically, you can use your calculator and do 270 divided by 180. Math enter gives you a simplified fraction there, and you're going to end up with 3 over 2 pi, or 3 pi over 2 radians, okay? So if I said I have 3 pi over 2 radians, it's the same as saying 270 degrees. Again, it's just another way of measuring, so don't get too caught up in it. So this one says convert pi over 6 radians to degrees. So again, which formula am I supposed to use? Well, it says pi over 6, that's your radians. You want to have degrees, so you want to cancel out the radians. Radians, think of it as pi, so you need to cancel out, you need to get rid of that pi. And when you look at the formula, it's 1 radian is equal to 180 over pi degrees. Well, to get rid of the pi, well, we want that pi to be on a separate level, or in that case, the denominator. So these pi's cancel out, so now there's no more pi, so I'd be able to have degrees, and I would just do the math here, and here is saying 180 divided by 6, because they're on different levels. I'm not cross-multiplying, there is no equals there. So 180 over 6 is 30, so 30 degrees is the same as having pi over 6 radians. And so there's kind of your crash course in it. All right, so now let's do a couple of examples here. Okay, so the first one here says circle B has a radius of 10 centimeters, and the measure of central angle B is 1.5 radians. Find the length of the intercepted arc. So if I'm going to draw that picture, here is circle B, and has a radius of 10. So I'll draw a radius, and I'll mark it as 10. It has a central angle B is 1.5 radians. So if I drew the central angle here, this is 1.5 radians. Okay, so it doesn't have the pi, but you have to kind of realize that it was kind of simplified out. So this is a radian measure. And what they want is they want to find the length of the intercepted arc. So they want to measure from here to here. And remember, in a circle, that would be talking about the circumference. So we've gone over a few times, well, to find the length of that intercepted arc, right, we would have to use the central angle divided by 360 times circumference formula, and you're either going to use 2 pi r or pi times diameter. That's the one that I usually like to use. Now, if you're going to plug in your diameter, since it said that the radius is 10, you know your diameter is going to be 20. Now this is where things get a little bit tricky. Here is talking about the angle. That angle has to be in degrees. So you're going to have to convert from radians to degrees. So 1.5 radians, okay? So to do that, again, you want to cancel out, so that means the pi is going to be on the bottom. So you're going to be doing 1.5 times 180 divided by pi. 1.5 times 180 divided by pi. Now what you're going to get is you're going to get a really ugly decimal. It's like 85.94 something like that, right? Big ugly decimal. That's going to go here, not rounded. Okay, you got to leave it alone. And that's going to be going over 360. Now you're going to say, well, do I have to write that whole thing? No. So you have your calculator. You did 1.5 times 180 divided by pi. Now, that number has to get divided by 360. So you take your calculator now with that big ugly number in it, hit divided by 360, then hit times pi times 20. And there you go. You're going to get a nice, beautiful number of 15, and this is measured in centimeters, so 15 centimeters. Okay, so it's just kind of a calculator work. And the only difference is, compared to what we were doing the other day, is I was giving you the degrees, now we're kind of talking about radians. All right, example 2. What is the measure in radians of the central angle of a circle that intercepts an arc of 1.5 centimeters if the radius of the circle is 3? So I'll draw the picture of the circle so I can kind of have an idea of what they're talking about. So the question says, what is the measure in radians of the central angle? So here's going to be my x. That intercepts an arc of 1.5 centimeters, which means the distance from here to here is 1.5. And it has a radius of 3. So there you go. Now this again is a length. We're talking about an angle, so we're going to use that same formula I used up above. So the angle divided by 360, that's my length, pi times diameter. So now the length here is 1.5, so they're really giving you the answer to this formula. X over 360 times pi times 6, because that number was 3. All right? So then now what you're going to do is you are going to basically just use your calculator. You're going to do some basic math here. So kind of try to follow along with me as I do this. So I have to get this x by itself. The first thing I'm going to do is I'm going to get rid of these guys that were getting multiplied. And we had done this earlier in earlier lessons. So you're going to have 1.5 divided by, now again, throw this in parentheses, 6 pi. Okay, 1.5 divided by 6 pi. And what you're going to get is, again, you're going to get a big, long, ugly decimal. And I wrote something like 0.0795, and there are more numbers there, equals x over 360. So the key here is don't ever clear the calculator. Okay? Then you're going to take that number, okay, if you look at this, again, here's kind of that cross multiplication, is you're going to multiply that big ugly number by 360 degrees, okay? And you're going to get 28.64 and a whole bunch more decimals that, again, you're not going to clear out, okay? So if you're following along with me, hopefully you are, you're trying to use your calculator so you can get an idea. If not, try to pause it and try to get these on your own. Now the question says, find the measure of that central angle, which we did in radians, but we found it in degrees. So we are now going to have to convert this into radian. So I'm going to multiply this by pi over 180. Okay, I'm going to multiply that by pi over 180. Now, we got some really ugly numbers in this one. We were throwing in the pi in there, and then all of a sudden, you went ahead and multiplied this by pi over 180, and I just got 0.5. Nice, pretty number. And there you go. 0.5 radians is the same as that 28.6 yada, yada, yada number. All right, and here we have some practice problems here. So here's exercise 1. Given the circle A, find to the nearest hundredth the measure of arc BC in degrees. Okay, so here's BC right there. Okay, now they said in degrees, so what that means is I need to figure out this angle since he's central, right? So you're going to go ahead and do some work here. And we are going to, we have what? Again, here's that length is 9. My radius is 15. And so if you want, give yourself a chance to try to figure out how to find the measure of the central angle similar to what we just did there. Okay, so we're just going to do some math here. They told me that the length is 9. The angle is what they wanted me to find. Pi times diameter. If you're using 2 pi r, then you have 2 pi times 15. Okay, and again, it's going to be just like up here. It's going to be some ugly numbers, but again, just let your calculator do it. Try to do it one step at a time. So the first thing we're going to do is we're going to get rid of that 30 pi. And again, if you don't have that in your calculator in parentheses, it's going to give you a different answer. So you're going to do 9 divided by, in parentheses, 30 pi. 9 divided by, in parentheses, 30 pi. Then you're going to get a big old ugly decimal number that you're going to leave alone. And then you're going to multiply that number times 360. And then again, to the nearest hundredth, you're going to get 34.38. And that is the measure of the central angle, which means that is the angle or the measure of the arc in degrees. Now they want to find, well, what's the area of sector BAC? So they want the area of this now. So very similar formula, except area is going to be equal to the angle over 360 times pi times radius squared, okay, because the pi times radius squared is the area formula. So we're going to use that number that we just used up there, 34.38 over 360 pi times 15 squared. Okay, don't be shy. Throw that whole entire thing in parentheses like that into your calculator, and you're going to get a nice number of 4.59. All right, hopefully that's helping you. And we'll turn it over. We'll try a couple more questions, similar to some older topics, but just kind of throwing in some of this new stuff that we did. So it says, find the area of the shaded region to the nearest hundredth if the measure of angle BAC is 62. So they only want this sector here. So think about what we had learned back in the past, right? So say I had this question here, and this donut right here, and I wanted the area of this outside. Basically what I would do is I would say, basically I have 2 circles, one large one, and then the small one is covering it. So if I found the area of this guy and I found the area of that guy, if I subtract it, basically take out the middle, you're left with that outside. And that's the same exact problem here, except you're going to be using just this sector, so that's why we're going to use this angle there. So again, you have basically 2 slices of pizza, right? Okay, one of the slices is here, and one of the smaller slices is here. So you're going to use those 2 slices to figure it out. So just so that we don't get too confused, because a lot of people will get confused. So one of the slices is large and one of the slices is small. They both have the angle of 62 degrees. Now, the large circle has a radius of AB, which would be 8. Okay? So you got to be careful not to just write 2. You have to write 8. And then the smaller circle, which would go from here to here, this guy here, has a radius of 6. So just make sure that when you're doing that one, you're using the correct radii. So let's start here. So the angle is 62 over 360 times pi times, again, we're doing the larger one, 8 squared. And then over here, same angle, 62 over 360 pi times 6 squared. You're going to go ahead and carefully put all that into your calculator, get a number. Go ahead and put all this carefully and get a number, and we're going to take those 2 numbers in the end, subtract them, and then round. Again, don't round till the end, okay? So take your time with it. So what I like to do, since this can get a little bit ugly, right, is I'll throw everything in except for the pi and kind of have exact numbers, or maybe you can do it and just write the whole thing down. So for this one, it was like 11.0222 pi, or if you threw the whole thing in your calculator, it's like 34.627. This one was a nice, pretty one. This ended up just being 6 pi, and then you end up putting that in your calculator. It was like 18.8495555. Subtract those two numbers, and you're going to get 15.78, and that is your correct answer rounded. But again, try not to round too early because you have the ability to kind of being off by 1 decimal place. All right, home stretch. 2 more questions. Okay, so this one, while in the face of it might look kind of difficult, it's actually a little bit easier if you break it down. So I want the area that's inside this rectangle. So let's just roll with the rectangle part real quick. Rectangle is length. Oh, that's ugly. Length times width. Well, that seems simple enough. Well, here you go. That's the whole length. Oh, I know what I'm doing. I'm hitting the button. Stop. No, undo would be easier. Let's go all the way back so it's not super ugly. So we were just talking about the rectangle. Rectangle we just said was length times width. So if you're looking at it, the length, the full length of this rectangle goes from there to there. That's 13. So the length is 13. Now the width is this number. Well, there's technically not a number there. But if you look at what that width is representing, it's representing the radius because it's going from the center to the end. And the radius of the circle, came from here, same there, is 5. So there you're just doing 13 times 5. Okay? So there you go. So there you're going to do 13 times 5. That's going to be 65. That's what's there. Next one. Now, basically, you want to take out this section and this section of the 2 circles, subtract those 2 sections out, and you'll have your answer. It's just your area of sector with a 90-degree angle. Radius of 5. So I would do 90 over 360 times pi times 5 squared. Now, if you think about it, there are 2 equal sectors, because these 2 guys are going to be exactly the same. So once I throw this whole entire thing in my calculator, I'm just going to multiply it by 2. And when I did that, I am going to get a number. It looks like I wrote down 39.2690. The number I got before that was 19.63495. Again, use your calculator. Make sure that you can do this on your own. Then you're going to subtract these 2 numbers, and you're going to end up with a number like 35.73, rounded to the nearest hundredth. Okay? Okay, hopefully this is helping. We got one more question to go. And this is there. Find the area of the entire circle given the area of just the sector. So what I'm telling you is I have the area of this, just this one slice of pizza. I want to know, well, what's the area of this entire thing, the entire pie, right? Well, if I just went ahead and broke it down and say there was another 72 here, there would be another 100. Say there was another 72 here, there would be another 100. Well, how many 72s can go into this circle? Well, how many total degrees you have in that circle is 360. Divide that by 72. It basically works out into 5 equal sections. Let's see if I did it. 1, 2, 3, 4. Oh, rats. 5. So it broke down into 5 equal sections of 100. So the answer is 500 is the entire area of the circle. It's 500 inches square. All right, so that covers everything we need to know about radians, a little bit in there, and then kind of reviewing some other stuff that we did earlier with areas of sectors and lengths of sectors. All right, have a great night, everybody.